The loaded cart train stretched behind Callum MacLeod like a wooden serpent across the snow, 5 carts deep, each stacked with cordwood that would have taken most men a full day to haul in separate trips. He had made the entire journey in under 2 hours, and not a single miner who had mocked his contraption 6 months earlier would meet his eyes now. Before we dive into how one man's obsession changed winter survival in the mining camps, let us know where you're watching from, and if frontier ingenuity stories like this move you, hit that subscribe button, because tomorrow's tale is even more impossible than this one. The sled wouldn't move. Fergus Darnley leaned into the rope harness across his chest, his boots digging into the packed snow, and pulled with everything he had. The sled lurched forward 6 inches. Behind him, Callum MacLeod pushed from the back, adding his strength to Fergus's effort. Together, they moved the overloaded sled another foot before it stopped again, the runners cutting deep grooves through the snow's crusty surface into the softer powder beneath. It was January of 1863 in the Colorado Territory, and the temperature had been below zero for 9 consecutive days. The mining camp where Callum and Fergus had spent the last 4 winters sat 3 miles behind them, and the stand of dead timber they had been harvesting sat 2 miles ahead. Between those 2 points, they were fighting to move 800 pounds of split firewood on a sled that had been designed for half that weight. They had no choice about the load. Winter in the high country consumed firewood at a terrifying rate. A single cabin required 4 cords of wood to survive the season. That meant cutting, splitting, and hauling approximately 5,000 pounds of wood before spring. Most miners worked in pairs, making the journey to timber stands and back dozens of times each winter. It was brutal work that consumed days that could have been spent prospecting or simply surviving. Fergus stopped pulling and bent forward, hands on his knees, breathing hard. Vapor formed clouds around his face with each exhale. He was 41 years old, strong from years of mining work, but the altitude and cold made every breath feel insufficient. Callum watched his partner's shoulders heave and felt concern tighten in his chest. They had been hauling wood for 6 hours, and this was their second load of the day. "We should rest," Callum said. Fergus shook his head. "Need to get back before dark. One more push." He straightened, adjusted the rope harness, and leaned forward again. Callum positioned himself at the back of the sled and counted to 3. They pulled together. The sled moved forward in a stuttering rhythm, runners scraping over ice and catching on hidden obstacles beneath the snow. They managed 20 yards before Fergus stopped again. This time, he didn't bend forward. He simply stood still, the rope harness going slack. Callum walked around the sled to see his partner's face. Fergus was pale beneath his weathered skin, his left hand pressed against his chest. "Fergus?" The older man's knees buckled. Callum caught him before he fell completely, lowering him to the snow. Fergus's eyes were open but unfocused, his breathing shallow and irregular. Callum pulled off his gloves and felt for a pulse at Fergus's neck. It was there, rapid and weak. "Stay with me," Callum said. He looked around at the empty landscape. No help, no shelter, nothing but snow and scattered trees and 3 miles to camp. Fergus's breathing stopped before Callum could decide what to do. Callum buried Fergus on a hillside, overlooking the timber stand where they had worked together for 4 winters. The ground was frozen, so he piled stones over the body and marked the spot with a wooden cross carved from pine. He didn't say words over the grave. Fergus hadn't been a religious man, and Callum didn't know what to say that would matter. He returned to camp alone, pulling the sled with its load of firewood. The journey took him 5 hours. His shoulders ached from the harness. His legs trembled with exhaustion by the time he reached his cabin. He unloaded the wood, stacked it against the wall, and sat inside, staring at the fire until morning. Over the following weeks, Callum began paying attention to how other miners hauled firewood. He watched them struggle with the same problems he and Fergus had faced. The methods varied, but none of them worked well. Some miners made multiple trips with light loads. They would fill a small sled or carry bundles of wood on their backs, traveling back and forth between timber and camp 6 or 7 times to accumulate enough fuel. This approach was safer than hauling heavy loads, but it consumed entire days. Time spent hauling was time not spent mining, and most prospectors were already operating on thin margins. Others attempted single heavy loads like Callum and Fergus had tried. These miners usually worked in pairs or teams of 3, combining their strength to move sleds loaded with 600 to 800 pounds of wood. The work was brutal and dangerous. Sleds broke under the weight, runners cracked. Men injured themselves pushing and pulling loads that exceeded reasonable limits. And sometimes, like Fergus, they simply couldn't handle the strain. A few miners owned horses and used them to pull loaded sleds. This was the most efficient method when it worked, but horses were expensive on the frontier and required their own feed and care. Worse, horses often died during harsh winters. Callum had seen 3 horses die in camp over the past 4 years, 2 from cold and 1 from breaking through ice while pulling a sled across a frozen creek. Dead horses meant miners lost both their investment and their hauling capacity in a single disaster. Callum started doing calculations in his notebook by firelight. He estimated each cabin needed 4 cords of wood per winter. A cord weighed roughly 2,000 pounds. That meant 8,000 pounds total per cabin. A man could reasonably carry or pull about 150 pounds without excessive risk. Simple division showed 53 trips required per winter. If each trip took 6 hours, accounting for loading, travel, and unloading, that totaled 318 hours of hauling labor per man per season. The inefficiency was staggering. Miners came to the territory to find gold, but they spent weeks every winter just trying to stay warm. The work was exhausting, dangerous, and apparently unavoidable. Everyone accepted this reality because nobody had solved it. Callum couldn't accept it anymore. Fergus had died pulling weight that shouldn't have been on that sled. The problem had a solution. It had to. Callum's obsession began with a simple observation. In late February of 1863, he was walking back to camp along a trail that dozens of sleds had packed down over the previous months. The surface was hard, almost like stone where the traffic and cold had compressed the snow into a dense layer. His boots barely left impressions as he walked. He stopped and knelt down, pressing his hand against the trail surface. It didn't give. The packed snow could support weight without the collapse that happened in fresh powder. Sleds with their broad runners distributed weight well, but they also broke through crusty top layers into softer snow beneath. That's what had happened with the sled that killed Fergus. The runners had cut through, creating resistance. Callum thought about wheels. Every miner in camp knew wheels were useless in winter. That was accepted wisdom. Wheels sank into snow. Wheels had no flotation. You needed runners for winter travel, just like you needed wheels for summer wagons. It was obvious. But was it true on packed trails? He went back to his cabin and spent the evening thinking about weight distribution. A sled's runners spread weight across long contact lines. Wheels concentrated weight onto small contact points. In soft snow, wheels would sink immediately, but on hard packed snow, maybe wheels would roll with less friction than runners that had to scrape across the surface. The next day, Callum walked to the camp's small supply depot and examined a broken wagon wheel that had been discarded the previous summer. He rolled it across the packed trail. It moved easily, the rim riding on top of the hard snow without breaking through. When he pushed it onto unpacked snow beside the trail, it immediately sank 6 inches and stopped. So wheels could work on packed trails, but packed trails were only part of the problem. Fresh snow fell constantly. Storms covered the trails. Even packed surfaces became slippery when new powder dusted over them. A smooth wheel would slip on any incline. Callum began studying traction. He looked at his boot prints in the snow, seeing how the rough leather sole created grip through tiny points of contact. He examined animal tracks, noting how hooves and paws left detailed impressions that showed texture. He thought about the wagon wheels he had seen in his life, remembering how iron rims sometimes had small ridges or irregularities that helped them grip muddy roads. What if a wheel was designed specifically for snow? Not a smooth rim, but a rim with intentional patterns cut into it, grooves that would bite into packed snow like boot treads bit into ice. He spent 3 evenings carving experimental patterns into a small wooden disc. Straight grooves, angled grooves, diamond patterns. He tested each version by pressing it into packed snow and trying to slide it. The deep angled grooves worked best, creating resistance that prevented slipping. Other miners saw him testing carved wooden discs in the snow outside his cabin. Henrik Lindgren asked what he was doing. Callum explained the wheel theory. Henrik laughed and walked away. Spring arrived in April of 1863, and Callum stopped prospecting entirely. He had made enough from his claims the previous season to survive, and he had decided to spend the warm months building something that might keep him alive through the next winter. Other miners thought he was making a terrible mistake, but nobody could change his mind. He started by selecting wood. Most miners used whatever trees were convenient, but Callum walked through the surrounding forest for 3 days looking for specific characteristics. He needed straight, grained pine for the cart frame, dense hardwood for the axles, and perfect cylindrical logs for the wheels. Each piece had to meet exact requirements he had calculated in his notebook. The cart frame came first. He designed it specifically for split firewood, with dimensions that would allow cordwood to stack efficiently without wasted space. The frame measured 4 feet long and 3 feet wide, with side rails 8 inches high. He used mortise and tenon joinery at every connection point, cutting the joints by hand with a saw and chisel. Each joint fit so tightly, he had to tap the pieces together with a mallet. The wheel construction took 2 weeks per wheel, and he needed 4. He started with the hubs, carving them from dense oak sections he had found near the creek. Each hub was 8 inches in diameter, with a 2-inch hole bored through the center for the axle. He cut mortises around the hub's circumference to receive the spokes. The spokes were pine, shaped with a draw knife, until each one was identical. 12 spokes per wheel, each 16 inches long, tapered from 2 inches square at the hub to 1 inch square at the rim. He fitted them into the hub mortises with adhesive made from boiled animal hide, then let them dry for 3 days. The wheel rims were constructed from curved sections of pine, steamed and bent into circles, then joined with precise scarf joints. But the rims weren't smooth. Callum carved his tread pattern into each one before assembly. Deep diagonal grooves, each 1/2 inch wide and 1/4 inch deep, cut at opposing angles to create a diamond pattern around the entire circumference. The carving alone took 4 days per wheel. When he assembled the first wheel and mounted it on an axle, it looked strange. The carved tread pattern made it appear rough and unfinished compared to the smooth rims of normal wagon wheels. Callum tested it by loading the cart with 150 pounds of firewood and pulling it across packed snow that remained in shaded areas. The treaded wheel gripped the surface without slipping. He built the second wheel, then the third and fourth. By late June, he had completed his first cart. The entire structure weighed about 60 pounds empty. With a full load of cordwood, it would carry roughly 150 pounds, bringing the total weight to just over 200 pounds on 4 treaded wheels. It worked, but one cart didn't solve his problem. He still needed multiple trips. That's when the real innovation began to form. Callum stood beside his completed cart in early July, studying the problem from a different angle. One cart carrying 150 pounds meant he still needed multiple trips to haul enough firewood. Building more carts was simple enough, but traveling back and forth multiple times with individual carts didn't save any labor. He would just be repeating the same inefficiency with wheels instead of sleds. Then he thought about wagon trains crossing the plains. Multiple wagons traveling together, but not independently. They moved as a connected line when conditions required it. What if carts could be linked together so one person could pull multiple loaded carts in a single trip? The engineering challenge was the connection system. The link between carts needed to be strong enough to transfer pulling force without breaking, but flexible enough to allow the train to navigate turns and uneven ground. Too rigid, and the carts would jackknife on curves. Too loose, and they would disconnect or tangle. Callum started with a simple tongue and socket design. He extended a wooden tongue 18 inches from the back of the first cart's frame and created a corresponding socket on the front of the second cart. The tongue fitted into the socket with an iron pin through both pieces to prevent separation. When he tested this connection by pulling both carts, it worked on straight paths, but failed immediately on turns. The rigid connection forced the rear cart to track exactly behind the front cart, and any deviation caused the tongue to bind or break. He needed articulation. He redesigned the connection using an iron ring and hook system. The ring was bolted through the rear crossbeam of the front cart. The hook was bolted through the front crossbeam of the rear cart and clipped through the ring. This allowed vertical and horizontal movement between carts while maintaining the connection, but the ring and hook alone created too much play. The carts would swing wildly behind each other, especially when starting from a stop or changing speed. He added guide ropes on each side of the connection point, running from the rear corners of the front cart to the front corners of the rear cart. The ropes limited the angle the carts could deviate from each other while still allowing necessary articulation for turns. Through July and August, Callum built 4 more carts identical to the first. Each took 3 weeks to complete because he maintained the same exacting standards for every joint and wheel. By September, he had 5 carts and had refined his linking system through dozens of tests. He connected all 5 carts in a train and loaded each one with 150 pounds of firewood. The total load was 750 pounds spread across 5 separate platforms. He attached a rope to the front cart and pulled. The train moved. The connections held. The treaded wheels gripped the ground. When he guided the train through a turn, each cart followed without disconnecting or tipping. The physics worked. Distributed load, modular failure points, maintained traction, but pulling from the front cart with just a rope was exhausting and inefficient. He needed one more innovation. Pulling 5 loaded carts with a rope attached to the front cart was technically possible, but physically brutal. Callum managed it for short distances, but the rope cut into his shoulders, and the pulling angle forced him to lean forward at an awkward posture that strained his back. After hauling the train half a mile, he was exhausted. The system worked, but it wasn't sustainable for the 3-mile journeys between timber and camp. The problem was leverage and ergonomics. A rope attached directly to the cart frame put all the pulling force on a single point, and that point was too low. Callum was essentially dragging the weight rather than pulling it efficiently. He needed to distribute the force and raise the pulling height, to use his body weight and leg strength instead of just arm and back muscles. He designed a pull bar. The concept was simple, but required precise execution. He started with a straight pine beam 8 feet long and 4 inches square, shaped smooth with his draw knife. The beam needed to be long enough to extend well forward of the front cart, giving him space to walk and pull without the cart hitting his heels, but not so long that it became unwieldy or created excessive leverage that could break the mounting. He mortised the rear end of the pull bar into a reinforced crossbeam he added to the front cart's frame. The mortise was 3 inches deep and pinned through with 2 iron rods to prevent any rotation or separation. The connection made the pull bar and front cart essentially one rigid piece. At the forward end of the pull bar, Callum installed a swiveling rope attachment point. He carved a wooden block with a hole through its center and mounted it to the beam with an iron pin that allowed the block to rotate. Through the block's hole, he threaded a heavy hemp rope formed into a loop. The swivel meant the rope could adjust to his pulling angle without twisting or binding. The pull bar extended forward at chest height when the cart was level. Callum could slip the rope loop over his shoulders like a harness, lean forward slightly, and pull using his entire body. His legs drove the motion. His back stayed relatively straight. The force distributed across his chest and shoulders instead of cutting into a single pressure point. He tested the system with all 5 carts loaded. The difference was immediate. He could maintain a steady walking pace, pulling 750 pounds across packed ground. The pull bar absorbed the initial strain of starting from a stop, and the swiveling rope attachment kept everything aligned through turns. After refining minor details like padding the rope loop with leather strips and adjusting the exact mounting angle of the pull bar, Callum had his complete system. 5 carts with treaded wheels, articulated connections, and an ergonomic pull bar that made hauling firewood a matter of walking rather than struggling. It was late September of 1863. Winter was coming, and Callum had built something nobody had seen before. The first person to see Callum's completed cart train was Alistair Drummond, a Scottish miner who had worked claims near Callum's for 3 years. Alistair watched Callum pull the 5 connected carts loaded with firewood past his cabin in early October, and his reaction set the tone for what followed. "Have you lost your mind entirely, MacLeod?" Callum stopped and turned. Alistair was standing in his doorway, arms crossed, staring at the cart train with an expression somewhere between disbelief and contempt. "It works," Callum said simply. "Wheels in winter? That's madness. Everyone knows wheels don't work in snow. These do." Alistair walked closer, examining the treaded wheels and the connection system between carts. He shook his head. "You've wasted an entire season building this contraption when you should have been working your claim. How much gold did you find while you were playing carpenter?" "Enough," Callum said, though it wasn't true. His prospecting income had dropped significantly. Word spread through the camp within days. Miners came to look at what they started calling MacLeod's madness. Some were simply curious. Others were openly derisive. Henrik Lindgren, who had laughed at Callum's wheel experiments months earlier, organized a small group to watch Callum haul firewood one afternoon. They made jokes loud enough for Callum to hear. "Built 5 carts when one sled does the job. Look at those ridiculous wheels. Wait until real snow comes. Wasted 3 months of prospecting season on toys." The criticism focused on several points. First, the wheels. Frontier wisdom held that runners were superior to wheels in winter conditions, and most miners couldn't understand why. Anyone would deliberately choose wheels for snow travel. The treaded patterns looked crude and unfinished to them, like Callum had simply failed to smooth the rims properly. Second, the number of carts. Why build 5 separate carts when one larger sled could carry the same total weight? The connection system seemed unnecessarily complicated. The whole apparatus looked fragile and overcomplicated compared to the simple, proven design of a sled. Third, the time investment. Callum had spent nearly 6 months building his cart train while other miners were working their claims. The financial cost was obvious. His gold production had dropped, his savings were depleted, and he had nothing to show for it but a strange hauling contraption that probably wouldn't survive the first real snowstorm. Even miners who weren't openly mocking the system questioned Callum's judgment privately. A few friends suggested gently that perhaps he had become too obsessed with solving a problem that didn't need solving. Men had hauled firewood using sleds for generations. The methods worked adequately. Why waste resources trying to reinvent something that already functioned? Callum didn't argue with any of them. He simply continued using his cart train. Every few days he made the journey to the timber stands and returned with 5 carts loaded with cordwood. The system worked exactly as he had designed it, but nobody seemed to notice or care. Winter was coming. The blizzard arrived on December 9, 1863. It started as light snow in the afternoon and by nightfall had become a full storm. Wind drove the snow horizontally across the camp. Temperature dropped to 20 below zero. The storm continued for 3 days without pause, then settled into a pattern of intermittent heavy snow and brutal cold that lasted 3 weeks. By the second week, every miner in camp was burning through firewood at twice the normal rate. Cabins had to maintain fires constantly to prevent freezing. Men were consuming their winter wood supplies far faster than anticipated, which meant emergency hauling trips in the worst possible conditions. Traditional methods were failing. Sleds that worked adequately in normal winter conditions couldn't handle the combination of deep, fresh snow over a crusty base layer. Runners would ride on top of the crust for a few feet, then suddenly break through into the softer snow beneath. The sled would stop abruptly, sometimes tipping and spilling its load. Pulling a loaded sled through these conditions required 2 or 3 men working together, and even then the progress was exhaustingly slow. The few miners who owned horses couldn't use them. The animals refused to work in the deep snow and extreme cold. One horse broke its leg when it stepped through a weak spot in the snow crust. The owner had to shoot it. Men were making multiple trips with light loads carried on their backs, but this approach consumed entire days for minimal wood. Several miners were showing signs of frostbite. One man collapsed from exhaustion and had to be helped back to camp by 2 others. Rowan Gilchrist's situation became critical in the 3rd week of December. He was a quiet Irish miner who worked a claim alone and kept to himself. His firewood supply was nearly exhausted, and he couldn't haul more using traditional methods. The deep snow and his own physical limitations meant he could only carry small bundles on his back, and even those trips were dangerous in the extreme cold. Callum found Rowan at the supply depot looking for anyone willing to help him haul wood. Most miners were dealing with their own shortages and couldn't spare the time or energy. Callum offered his cart train. Rowan looked skeptical but desperate enough to accept. They made the trip together. Callum's treaded wheels performed exactly as he had designed them to. The tread patterns bit into the packed sections of trail and provided grip on the crusty surface. When the wheels did break through the crust, the distributed weight across 5 carts meant they didn't sink as deeply as a single heavy sled would have. The pull bar and rope system let Callum maintain steady progress even uphill through difficult sections. They completed the journey in 4 hours and returned with 750 pounds of firewood. Rowan estimated it would have taken him 12 trips carrying wood on his back, assuming he could physically manage that many trips in the cold. Word spread quickly. Other miners started asking questions instead of making jokes. By January of 1864, 3 other miners had started building their own cart trains. They came to Callum asking for measurements and construction details. He shared everything freely. He showed them his tread pattern designs, explained the articulated connection system, demonstrated how the pull bar mounted to the front cart, and gave them the dimensions he had calculated for optimal cordwood stacking. The first imitator was Declan Rafferty, a young miner from County Cork who had arrived in camp the previous spring. He built a 3-cart version, reasoning that he lived alone and didn't need the capacity of 5 carts. His construction was cruder than Callum's. The wheels were less precisely round and the tread patterns were shallower, but the system worked. Declan could haul 450 pounds of firewood in a single trip, which was 3 times what he could manage with his old sled. Henrik Lindgren, who had mocked Callum's wheel experiments 9 months earlier, built a 4-cart train in February. He didn't apologize for his earlier ridicule, but he did ask detailed questions about joint construction and wheel hub design. His version incorporated some modifications based on available materials. He used iron straps to reinforce the frame corners instead of relying solely on joinery. Alistair Drummond waited until March before building his own version. His sled had broken completely. During a hauling trip in late February, spilling 200 pounds of firewood into a ravine and destroying the sled's frame beyond repair. He built a 5-cart train nearly identical to Callum's, though he added wooden side panels to each cart to contain smaller pieces of wood that might otherwise fall through the rails. The technique spread beyond their immediate camp. Miners traveling between camps saw the cart trains and asked about them. Some sketched diagrams. Others simply observed the construction and replicated it from memory when they returned to their own locations. By late spring of 1864, variations of the cart train system were appearing in mining camps throughout the Colorado Territory. The designs varied based on available materials and individual skill levels. Some miners built larger carts with 6 or 8 wheels instead of 4. Others experimented with different tread patterns or connection mechanisms. A few tried using iron wheel rims with welded tread ridges instead of carved wooden patterns. The fundamental principles remained consistent across all versions: treaded wheels for traction, multiple connected carts for load distribution, and pull bars for leverage. Nobody called it McLeod's system or gave Callum credit by name. The innovation spread anonymously as a practical solution to a common problem. Miners who built cart trains simply referred to them as hauling carts or firewood trains. Younger miners arriving in the territory saw the carts and assumed they had always been standard equipment. Callum returned to serious prospecting in the spring of 1864. His cart train sat beside his cabin, used routinely for hauling, but no longer remarkable. The innovation had become ordinary through widespread adoption, which was exactly how useful things spread on the frontier. Callum McLeod left the Colorado mining camps in 1868. Gold production had declined throughout the territory as the easily accessible deposits were exhausted, and many miners were moving on to new strikes in Montana or returning to settled regions. Callum took his savings and traveled north, eventually settling near Helena, where he worked various jobs before buying a small ranch in 1872. He never spoke much about his years in the mining camps. His cart train system had been left behind, abandoned at his old claim, along with the cabin and equipment he couldn't transport. Other miners probably salvaged the carts for parts or continued using them until they wore out. Callum had no way of knowing and didn't particularly care. The innovation had served its purpose. The cart train system persisted throughout the Colorado Territory and spread into Wyoming and Montana mining regions through the 1870s and 80s. Variations adapted the basic design for different cargo beyond firewood. Miners used cart trains to haul ore from remote digging sites to processing areas. Supply merchants built larger versions to transport goods between camps. The treaded wheel concept influenced other frontier transportation designs, including specialized snow wagons and ore sledges. By the 1880s, most mining camps had at least a few cart trains in use. The designs had evolved considerably from Callum's original construction. Some used metal frames instead of wood. Others incorporated spring suspension systems or improved bearing designs for the wheel hubs. But the core principles remained: treaded wheels for winter traction, multiple connected units for load distribution, and pull bar systems for efficient human or animal power. Nobody remembered who had invented the system. A few old-timers in Colorado might have recalled a Scottish miner named McLeod who built strange carts during the winter of 1863, but even those memories were vague and often contradicted by other recollections. Some miners claimed the idea came from Scandinavian logging techniques. Others insisted they had seen similar carts in use in the Sierra Nevada before the Colorado Gold Rush. The origin became obscured by time, and the natural human tendency to assume useful things had always existed. Callum died in 1889 at age 54 from pneumonia. He was buried in a small cemetery outside Helena. His gravestone listed his name, birth year, death year, and nothing else. His wife and 2 children knew he had been a miner in Colorado, but he had never told them detailed stories about that period of his life. To them, he was simply a ranch hand who had worked hard and died relatively young. The cart trains he had pioneered continued operating in remote mining camps into the early 1900s. A few examples were eventually donated to historical societies or preserved as artifacts of frontier mining life. Modern historians studying 19th-century mining technology occasionally note the cart train systems in photographs or written records, but the invention is typically attributed to anonymous frontier ingenuity rather than any specific individual. The story illustrates how innovation actually worked on the American frontier. Solutions emerged from immediate necessity rather than theoretical design. A man watched his partner die from exhaustion and decided the problem required engineering rather than simply accepting loss as inevitable. He combined existing technologies in new ways: wheel treads for traction, modular carts for distribution, mechanical leverage for efficiency. The result solved a genuine problem, so it spread organically through communities that needed it.